Hello everyone, we are back. Today we are looking at the Earth. I was just talking about Emmanuel Velikovsky, going back, revisiting some of Michael Steinbacher's work. And while I'm doing this, I had to bring up Emmanuel Velikovsky because what I want to talk about in this video, it's going to get a little intense. We're going to look at the Earth. I'm going to explain what's going on here. I gotta go back to the physics and explain what was happening to the Earth. While this may have been going on, when we apply our right-hand rule to our scenario where we have the moon orbiting one object as the Earth is orbiting another, while the Earth goes in to capture the moon, if these two larger potentials get closer, you have the Earth coming in one direction, the moon's going to be coming back into the other direction. We've considered the possibility of starting the Earth off tidally locked during the time of Pangaea. And right here I'm going to try and explain this. Gets really difficult to try and wrap your head around, but I'll try and make it as easy as possible. So if the moon's coming into one side, think of this as the side with the Americas, but kind of ignore their shape and just imagine this right here is the land side of Pangaea Earth. I'm going to take you back to the orbit. So on this, the land side would be facing out at all times as it comes out here. And when it gets over here, in between these two, the moon would be coming in to strike the land side on Pangaea Earth. So the moon's not coming in here. The moon would technically be coming in here and striking this side. But if we're looking at this potential right here, we're looking straight ahead at the Earth, centering right around here in Africa. I'm going to take you over to the map. This would be the direct land side of Pangaea Earth, right about here. Which is hard to wrap your head around what's going on to make it look like this to this, because it almost looks like this is all folding down in here, this is all folding down in here. And I think what's going on, when you come back to the right-hand rule and you apply it over to this scenario, when we explained when the Earth gets too close to the moon, you apply the right-hand rule, the moon gets tidally locked. Once the electric current goes this way, the force of motion wants to go this way in the 90-degree perpendicular. But I think there's a different reaction that's also happening to the Earth to send it in the 90-degree. You apply the right hand, but it's just torquing over on itself, I think, is what's going on. So I'm going to show you on this map. We'd be looking directly right here from this potential when the Earth side is facing out. But when that happens, I think the Earth will be between these two and it folds over 90 degrees on itself. Let me explain. It's hard to see from the satellite images. We can zoom out. This is where Michael Steinbacher was at, but in the other videos, I went down to the continent of Antarctica, traced this current up through South America. We came up, down here, around here, up in here, all the way over, coming back in, tracing these dragon features back over in here, all the way right back to where we started. Now, I think what was happening, there was two things going on. When we come over to our satellite images, this is a vast ocean in the Pacific side. This whole side is. But when you look at Pangaea, that would be the other side of Earth. So that's this hemisphere this is in the south. And I think this potential actually wound up in the north when this was going on. It's very difficult to wrap your head around looking at these maps, but when you come up here, you see this little plume up from here. It jets up and over, and it comes back over around over, and this is where you get the arc down in the pole flip, I believe. But as this is happening, I'm going to take you over, because this started, we were looking at the southern continent of Antarctica. Now let's look at the northern. You see this rim? It's like a very distinct band along the Pacific. And you almost got a current that flows from here to here to here and in. But here's this jet up. So on this map, you can imagine this is the Pacific. This is the side that would be facing in starting off. It was facing in. And then when you come back over here, it winds up to the north. So you got to imagine starting off here in the Pacific, 90 degrees over to the north. While that's happening, on the other side, wherever it started off over here, that's going to flip back down to the other side of the hemisphere, and that's going to come back around to the south. Does that make sense? I hope so. I'll try and explain it on this map. So when you come over here, this is like the center point. And then this side over here is basically the same as this side over here. So as this is going down, this is coming up. Does that make sense? Try it again. So if you come over here to the Pacific, wherever the middle is, as this is going up, you can come over here, this is coming down. See over here, this is coming down. This is going up, this is coming down. So there's something opposites to how we need to take this, start from Pangaea, smash apart the continent, tidally lock the moon. These two potentials need to balance the charge. That causes the pole flip. And all this happens in one big event. Which is how Michael Steinbacher was describing it. What he saw on the features of Earth. And when you look at the Pacific, this is still like a pretty big vast ocean. So it's not hard to draw. Like you can look at this. This takes the whole... This is a lot of water over here. And I actually have this started off on this image, even though... But you can see there's a chain, a chain, a chain, and it funnels right back down into there. You can see the crack into this is the resistance into this sphere. But the charge is going around in this direction. As this is happening, it's either going to go into here or back around. And it's pretty much this band from here over, it all comes back around. And everything on this side comes back up and in. And same thing up here. It's working its way back along and in. Along and in on this side. On this side, it's the actual resistance of the Earth. So what you also have to imagine, you're starting off as Pangaea. We already explained if it was a flaring dwarf star, you could actually get the excavation on one side of the planet and accumulation on the other to cause the features where you have the land side on the far side of the planet, if this is tidally locked over any serious extended period of time where you get one side's always exposed to a flaring star, which could turn into a gas giant later, especially if it were to crash into a solar system at some point in time in the past. Now, what's crazy is when you bring up the notion like Velikovsky did, as this is some kind of more recent event, the science goes into an outrage. If you send it in from the catastrophic perspective, but when you're taking it in from their perspective, it doesn't make sense to explain these features in a slow and gradual process. If it's something that's going on at this scale, and they don't even want to apply the laws of physics, they want to keep this stuff out of it, because to them, when they see a pole flip, they don't want to think of anything at all that might enhance this rate of spread, because it completely destroys the uniformitarian mentality, which is not scientific, because they're like in complete denial of actual physics. So what I was originally trying to show down here is what's happening from the south, and this is another image that's really clear. It like draws itself in as this unwraps itself out, but this focus comes back down into here, and this is what Michael Steinbacher was alerting me in a lot of his videos, was to stuff down here in Africa. Like this is all being pulled, drawn in down here, but at that time there's all this stuff going on to the north, even though the side, when you go to the orbit, the water side used to be facing this, but when you look at the Earth, it flipped. Not poles, but in reality, when you go to Pangaea Earth, the North Pole is still in the same spot. It just got shifted 90 degrees to where, if we were looking at it like this from the start, it would be in the complete opposite side of the planet. Shifted from down here would be up here would be up here, if that makes sense. So that was the torque that was being applied to our planet, and you can kind of play around with it for yourself to see there's a locking of the moon, but the Earth's forward progression temporarily gets disrupted right in here when the moon comes in, and it gets shifted to the 90 degrees, and then there's the pole flip between these two. I hope that explains. There will be more in time. Thank you, everyone. Take care.